Hello and welcome to the first session on inductive sequences. We can see here we have an inductive sequence given by this formula. It states that to find a term in the sequence, we take the previous term and then add 4. In this case, the first term is 7. We're going to find the first 4 terms. So to find the second term, which will be U2, we first take the first term, 7, and add 4. So the second term is 11. We continue this to find the third term, taking the second term, 11, and adding 4. So the third term is 15. The fourth term, U4, we take 15 and add 4, giving us 19. We have now found the first 4 terms of this sequence. Here is another inductive sequence where a third term in the sequence can be found by looking at the second and first term. The first term, U1, is 2, second term, U2 is 5. Let's find an expression for U3. So U3 is found by doing m lots of U2, which is 5, and adding U1. So in this case, 5m add 2. We then take U3 and U2 to create U4. So m lots of the previous term, in this case U3, add on the terms 2 previously, so U2. Now we can expand the bracket and we have an expression for U4. So 5m squared plus 2m add 5. We have now answered this question. We can extend this, however, and try and find values for m if U4 is 21. We have been given a hint in the question by saying find values and not just value. From previously, we know 5m squared plus 2m plus 5 is the expression for U4, and we now know this is 21. We can now rearrange the formula, as it's now quadratic, to make it equal to 0. And we'll take away 21 from both sides, leaving us with minus 16. We can now factorise. Finding that we have 5m minus 8 and m plus 2. We can clearly now see that m would be either 8 over 5 or m can be negative 2. Here we have an inductive sequence, un plus 1 equals 1 minus a quarter un, where the first term is 1, and find the limiting factor when n gets very large. This means that the sequence will move towards the same number for every term. As n gets very large, un and un plus 1 become practically the same value, so we can replace this with L. You can test this by putting in un equals 1 into the formula and generate a few values. Keep going to about the 10th and you'll start to see that they converge to a certain value. If we take this new equation we have formed and multiply it by 4, and then move an L to the other side and solve, we can find the limiting factor. In this case, the limiting factor would be 4 over 5. This is all you need to know for inductive sequences.